All right. Greetings, everyone. Now, what we are going to be looking at, basically, we are going to be looking at empirical formula, right? Now, the simplest way of, explaining empirical formula, basically, here we want to understand the simplest ratio, in terms of percentage in which, a certain compound also contribute within a particular reaction, right? Now, so what you need to know about an empirical formula of a compound is that now it can be found from a percentage composition, right? So now, firstly, we are saying now this it can be found from percentage composition. So which means when you have percentage composition, you can be in a position now to determine what is going to be the empirical formula. And now also what you need to know is that we also assume, so we assume that now your let's say your 100 grams is going to be the one that is analyzed, right? We assume that your 100 gram is the one that is analyzed. And now, secondly, what we also assume is that now, let's say you are given it in terms of percentage. If you are given it in terms of percentage, what you need to know is that even those percentage, right? Now, if you are given it in terms of percentage, those percentages also must be or can be converted into what? Into grams. Now, for example, if you had 100%, right? If you have 100%, all those percentage are going to be converted to 100 grams, which means whatever percentage that you have can be converted into 100%. Now, let's look at this particular example and see what can we do to find the empirical formula of this one. Now let's start here. Now, firstly, they say an oxide sulfur contains, your 40% of your sulfur and 60% of oxygen by mass, right? And now determine the empirical formula of these oxide sulfur. Right now, the first thing that you're going to do is your step number one. Your step number one, we are going to convert all these elements. So we are having percentage elements, right? Percentage elements. So now, what was the percentage of your sulfur? Your sulfur, it was given that this is 40%, right? And this is 40%. And your percentage of your oxygen, you are given that this is 60%. So now this is going to be your first step. So you're going to represent all these, or rather all these in terms of percentage. Now, this step number two that we are going to undergo is that now we are going to we're going to convert it into mass, right? So we are going to have now the mass of the particular element. You're going to have the mass of the particular element. So if this is 40%, so this is going to be now converted into 40 grams. And this, since this is 60%, this is going to be your 60 grams. So now this is going to be your second step. Now let's see in terms of what is going to be our third step. Now our step number three. Now, our step number three, basically now we are going to use, or rather we are going to calculate the mole using the formula mass over your molar mass, right? Now, what is going to be the mass of your sulfur? The mass of your sulfur, we're given that this is going to be your 40 grams over. Now, what is the molar mass of your sulfur? The molar mass of your sulfur, it is going to be your 32. So the totality of this in terms of moles, this is going to be 1,25 mole, right? And then now, what is it that you're going to do? Similarly, this side, you're going to take this as 60 grams over what is going to be the oxygen. Oxygen is going to be 16. And now your answer that you're going to get here, it is going to what? Now, this is going to be same as what? This is going to be 3,75. 3,75 mole. Now, this is going to be your basically this is going to be your what your mole that you're going to have. Let's write this nicely here. Now, then now let's see. Now, what is it that you are going to have also after this? Now, from here, now we are going to do now the last step, which is the smallest mole ratio, right? This is going to be your step number 4, which is we are determining the smallest mole ratio. right? That's what we are going to do. So basically now when we're determining the smallest small ratio is we are going to come here in this block and we are going to look for the smallest mole, right? Then the smallest mole, you are going to be the one that you use to divide, right? So you're going to use it to divide. And when you use it to divide, you are going to divide everything. So let's come here between 1,25 mole and 3,75. Which one is the smallest mole? Basically, it's going to be the 1,25, right? So you're going to come in here, say 1,25 divide by 1,25, right? And then now what are you going to have there as ratio? This is going to be 1. Then you come back here, you are having 3,75. You divide it by 1,25. And what are you then going to have here as your ratio? This is going to be 3. So which means now from here, what is going to be then the empirical formula? The empirical formula. So the empirical formula for this is going to be what now? We are going to take the ratio. What is your sulfur? Your sulfur, it is S. And what is the ratio for sulfur? It is 1. So this is same as your what? This is same as your 1. But S1 is still the same thing, right? And your oxygen, it is given by what? It is given by 3. So this is going to be your 3. Okay, so now this is going to be the empirical formula of this particular reaction. Now let's look at something else. Now let's look at this second example. Now they say a sample of oxide of copper contains 8 grams of copper and also combined with 1 gram of oxygen. Now they want us to find the empirical formula of this. Now we are going to also follow the same steps. But what you can realize now is basically that now we are given this in terms of grams, right? We are already given this in terms of grams, so there's no need for us to undergo the step where we convert the percentage into grams, right? Now, so what we're basically going to do now here is we are going to start here. Now, which means now the first step in this particular one now, your step 1, it is going to be what now? We are going to just represent the mass of the elements. We're going to represent the mass of the elements. Remember the first one, it was the percentage, but because now we don't have percentage, we are going to go straight to the mass. Now, the mass of this element for this one is going to be what? This is your 8 grams, and this one is given by you 1 gram. So this is going to be the mass of these elements. Now, let's go to the next step then. Now, what is going to be our second step? Our step, your step number 2 is we are going to now in this one look for the mole now. So we are going to say N is equals to your M over your capital letter M, right? Now let's continue. Now, basically, you are given that the copper is given by 8 grams over what is now the molar mass of your copper. Your molar mass of your copper, I think it's 63,5, right? And now, therefore, what is going to be the mole of this? The mole that you're going to get here, this is going to be 0,126 mole, right? This is going to be 0,126 mole. Similarly, this side is going to be 1 over what is the molar mass of oxygen? The molar mass of oxygen, it is going to be 16. Now, if the molar mass of oxygen is 16, what is the answer that you're going to get here? This is going to be 0,0625. 625 mole. So this is going to be your mole of oxygen. Then now we continue. Now our step 3 for this one, our step 3 for this one, we are going to determine now the ratio, the atomic ratio. And now remember again, we said we divide by the smallest one. So if you can check, the smallest mole between the two is the one of 0,0625. So we are going to say, we'll start here, 0,126 divided by 0,0625. What is it that you're going to have? So you're going to have approximately your 2. And now what you're going to have now here, this is going to be 0,0625 dividing again with 0,0625. And what you're going to have here is the ratio is going to be 1. And after that now, you are going to write what is going to be the empirical formula for this. And what is going to be the empirical formula for this? You are going to say, now what is your copper? The symbol for copper, it's your Cu. And what is the subscript for it? It's going to be 2. Now, while your oxygen is going to be 1 and oxygen the same as 1, that's the same as your Cu2O, right? Because this is one and the same thing with the oxygen. Now, let's check the last example. All right, now let's look at this particular example now. They say now a certain nitrogen and oxygen with the general formula of N with it, which is X, and O, which is Y. Basically, the X and Y represent, your unknown subscript. Then now they contain what? Contains 6.8% of nitrogen. Determine the empirical formula. Now this one is very much important, firstly, to realize that the only percentage that you are given the percentage of what? You are given the percentage of your nitrogen. And you know that both of these, the nitrogen and also the oxygen, must add up to 100% at the end, right? So that's where you're going to start, which means, therefore, now your percentage of your oxygen, you're going to start with it. It's going to be your 100% subtract your 36.8%. And what you're going to get there as your percentage, it is going to be 63.2%, which is going to be now your percentage of your oxygen, right? Now that's the first step. Now, after that, now we are going to come and present this into our table. Right. Now, therefore, we are going to try and represent this in terms of our steps. So this is going to be the steps. Now this is going to be the block that represent your nitrogen. This is going to be the block that represent your oxygen. So the first thing, your step one, basically, you are going to present this in terms of percentage, right? It is going to be the percentage of elements. Now, what is going to be the percentage of nitrogen? It is 36.8%. And now what is going to be your oxygen? Now we've already calculated it, so it's 63.2%, right? So that is going to be your first step. And now if we are moving to our next step, what is going to be our next step comprised of? So our step 2, now we are going to convert this we're going to convert this thing now into what? Into grams. Into grams. So the percentage is going to be same as now 36.8 grams. This is going to be same as 63.2 what? Grams. So now we've converted all of these compounds of ours in what? In grams. Then now we are going to look at our step 3. Now, what we need to take note in step 3, now we are going to use the mole formula to calculate what is going to be the mole. Now, let's start here. Now, already you have this in terms of grams. So, now this is going to be same as 36.8 grams divided by, now what is the molar mass of your nitrogen? Your molar mass of your nitrogen, it is going to be your what? It is going to be 14. So, therefore, what is going to be the moles that you are going to get here? It is going to be 2.63. Now, this is the mole that you're going to find. And this side, when you come this side, this is 63.2 grams, right? Divide by what is the molar mass? It's 16. And therefore, what is going to be the solution that you're going to get there? It's 3.95, right? Now, so this is going to be what you're going to find. Now, let's continue after that. Now, after that, now what we're going to do now, we're going to divide, right? So your step 4 now, in this one, you're going to find the ratio through division. Now, when you check between these moles, which one is the smallest mole? This one is going to be a smallest mole. So you're going to say 2, 2.63 over 2.63. Then you are going to get the ratio of 1. Then when you come this side, it's going to be 3.9 5 divided by 2.63, right? And you'll realize that what you are getting this side is going to be what? It is going to be 1.5, right? Now, to represent this 1 and also 1.5, basically, now when you write this in terms of whole number, this is going to be the same representation of what? Same representation of 2:3. 1 and 1.5 is same as 2:3, right? So which means now the empirical formula for this your empirical formula here is going to be your N, which is going to be 2 now, and then the oxygen, which is going to be your 3. So this is going to the empirical formula of this particular question.